I'm moving. Just quickly, I will always try and wait on a question for you to take screenshots after I've done an answer. But if for whatever reason I move away too fast, you can just say you need me to go back to take a screenshot. Okay, it's not a problem at all. Right, so I'm just going to skip question 1 mostly because I want to focus on the really important stuff that we need to know for grade 9. We'll come back to the other stuff, but I want to start with the really important stuff. Okay, so this first question that we're going to have a look at is talking about simplifying expressions. Okay, now when we simplify expressions, there's lots of different things that we need to remember when we simplify expressions, but basically the goal is to take what we've been given and shorten it or make it a simpler version of what it is. And to do that, we have to look for things like terms. We have to look and see if there's fractions we can simplify, if there's multiplication we need to perform, etc., etc. So there's a couple of things we need to bear in mind and we need to think about. And as Naledi said on the chat here, if we look at our very first question, 2.1, we have got 6 different terms here that we now need to deal with. Now, quick reminder, terms are sort of like the words in a mathematical sentence. They are different parts of the expression that make up the whole expression. And terms are separated by plus and minus signs. So our 6 terms here are all separated by these plus and minus signs that we have here. And this is how I knew I had 6 terms. Obviously, I hope I can count if I can count. So 6 terms. And each of those terms represents part of my expression. Now, if we don't have to multiply or divide or anything like that, and we just are adding or subtracting, this is now when a lady's statement comes very important. We now need to look for like terms. So can anyone remind me, you can either put it in the chat or you're welcome to raise your hand. What are like terms? Like when I say like terms, what do I mean? Kabiso, I need to actually unmute you. Kabiso, what are like terms?
Like terms are terms that have a variable that is raised to the exact same exponent. So for instance, 4x to the raised to the power of 2 is the like term to negative 3x raised to the power of 2. Thank you.
Excellent. Well done. Exactly. And what was really important there, guys, is the fact that it is the same variable with the same exponent. So here, exactly as we've been told, the 4x squared and the negative 3x squared, those are like terms because not only do they both have x variables, they both have an exponent of 2, and that's really important. And so now when we go and collect our other like terms, we've got x terms, so the variable x with an exponent of 1, and then the plus 8x. And then we see we've got 2 terms here that are just numbers. Does anyone remember? You can just quickly type it in the chat. What do we call terms that are just numbers? There's a special word we have for those sorts of terms. Excellent. Well done, guys. Tato, what are they called?
Ma'am, they're called constants.
Excellent. Well done. They are constant terms or constants. So if we do not have a variable, excuse me, there's no variable and it's just a number, it is constant. Okay, so now we've got all of our terms grouped together. This is now where we now need to start simplifying. I don't know if my pen's going to work, but let's try. Let's see what happens. Right. So if we now want to go and simplify this expression, you have got many options at your disposal. Some people like to first write the terms or the like terms group together so that they can see exactly what it is that they're working with. That is absolutely fine. If, however, you don't feel like you need to do that, that's fine. You don't need to do this step. You can go straight to your answer. Right, so I can see Rebecca has put an answer here on the chat. That is awesome, well done. If we go and first simplify our first group of terms, we've got a 4x squared minus a 3x squared. Now the exponent and that variable isn't going to change. So it's still going to be an x squared. And now I need to think, okay, well, I've originally got 4. I'm taking away 3, which means I'm left with 1x squared now. Now you can write the 1 if you want to. You don't have to. If you just write x squared, that's fine. Right, when we go to the next group of terms, we've got a negative 7x plus 8x. And Rebecca has put there, it is positive x, which is perfect. We're going from a negative 7, if you imagine your number line, and we're adding on 8. So we're going back into the positive values on my number line. And so what we now have here is a positive 1x, or you can just write x, absolutely fine. Or maybe I should also write the actual numbers in. Right, our last one, we have got plus 1 minus 2. So again, think of your number line. You're starting with 1 and you're taking away 2, which means we're now moving into the negative values. And so again, as Rebecca said here, we've got a minus 1. Now there are no more like terms. I can see that there are no more like terms because we don't have any of those same variables and exponents. And so that is where I stopped. Now we can see that this is simplified because I've gone from an expression of 6 terms to an expression of 3 terms. I've condensed it, I've simplified it. It still means, or it still says the same thing. I've just put it in simpler words. Okay, so that is the whole point of simplification. If you want to take a screenshot, I'll hang here for 2 seconds and then we're going to have a look at 2.2. Which actually everyone can see 2.2. If you want to give 2.2 a try straight away, go for it. 2.2, you can see here, is a minus 5x times the bracket 2x minus 3. So give it a try. We're multiplying here. So just think about what that means. Remember, there's variables involved here. So Naledi, very close. Just remember your variables and check your signs. I'm hoping everyone's got a screenshot. I'm just going to move this down. Okay, and as Nalisa has put on the chat, remember, we are multiplying x times x. So think about what happens when we do that. Okay, let's have a look. We're getting really, really close. And I'm loving that we're now thinking about the exponents here. So if we go to our expression, what is happening is that this negative 5x is being multiplied or must be multiplied with both terms in that bracket. Very nice, Theo. Right, so if you are comfortable to do this just quickly in your head, go for it. What I'm going to do, though, is just because we need to make sure that we're all comfortable with this multiplication, is I'm going to do the multiplication on the side here. You are welcome to do a little like side bit of working out as you go along, excuse me, but we're just going to do it step by step. Now, one of the ways I like to, oh no, that's the wrong words. One method of doing or making sure that we multiply and divide correctly is to remember SNV. Now, SNV is a little trick or a little method that we can use to correctly multiply and divide. Now, S stands for signs, N for numbers, V for variables. Now, basically what this means is if we deal with each one of those individually, we will be able to multiply correctly. So if we start with the signs here, quickly in the chat for me, what do I get when I multiply a negative and a positive? What sign is my answer when I say negative times a positive? You can just put in the chat for me. Kulunga, what do we get?
We get a negative.
A negative, excellent, well done. So guys, when we have a negative times a positive, we get a negative. So that's my signs part of my little reminder done. Excellent, everyone on the chat. Then we go on to the numbers. So now all I need to do is say, what is 5 times 2? That's nice and easy. We know that 5 times 2 is 10. And then we need to go on to the variables. And now this is what Nalisa was trying to sort of hint to us earlier. When we've got variables that we are multiplying, this needs to take us back to our exponent rules. And when we multiply with exponents, as has been said on the chat here, we go and add the exponents. So here, both of these x's have an exponent of 1. So if I say x times x, what I end up with is an x squared. Let's see if this works for me. Okay, and so negative 5x times positive 2x is negative 10x squared. So that's the first multiplication that we needed to do. The second one was a minus 5x times a negative 3. So quickly on the chat, what sign do I get when I multiply a negative and a negative together? What sign will my answer be? Very nice, guys. Where to? What sign do I have?
Positive.
Positive. Excellent. Well done. When I multiply a negative and a negative, we get a positive. Now you can write the positive there to remind yourself that it's going to be positive. You don't have to. It's not necessary because we know that if there's no sign in front of a term, it is positive. Really up to you. That again, sign's done. Now we go to the numbers. 5 times 3. Nice and easy again. We know that's 15. Now, when we get to the variable, we need to be mindful of the fact that there's only one x there. There's no x in the second term. So we're not going to have this addition of exponents like we did in the last one. And so because there's just one x that I'm dealing with, it's just going to be 15x. I don't need to stress about anything else. And so now I can go and write down my products for myself, which were minus 10x x squared plus that 15x. Now, can someone tell me, you can either raise your hand or you can put in the chat, can I simplify this expression further? Like, is there more that I can do to simplify this? Emmanuel, tell me.
I don't think so, ma'am.
Why not?
I think it's reached this limit, ma'am, because the like terms, ma'am, there aren't any like terms.
Excellent. Well done. We don't have any more like terms. X squared and x are not like terms. We can't add or subtract. There's nothing more that we can do here. This is it. I have simplified as far as possible. I stop. So what we need to remember is like terms is always something we need to check for. Once we've done the multiplication, once we've done the division, once we've done all of that, we always need to double check. Have I added all of the like terms? Because if we haven't, we have not simplified fully, and we need to simplify fully. There's no like terms here, so I'm done. I can move on. Right, but the multiplication here, remember your signs, what happens when you multiply a negative and a positive, or a negative and a negative, and remember that when you multiply variables, there's that exponent rule that we need to bear in mind. Okay. Right, I did see that there was a question to just quickly go back to the first one. So what I'm going to do is I'm just going to do that so that everyone can see both. And if you need to take a screenshot of both, you can. And then we're going to have a look at 2.3. (2.3) is missing an x there. It should say 10x cubed. I will fill it in now. Okay, last 3 seconds for screenshots. Right. Okay, so sorry. Don't know how I missed that. This should say 10x cubed. The lady, when you say please scroll down a little, which way do you mean? Is this now fine? Cool. Okay, so guys, here we've got a fraction situation. Again, we're wanting to simplify, but now we've got a fraction that we need to deal with. Now, fractions we know means division. Okay, so the lady's already asking to answer this one. So the lady, do you want to maybe raise your hand and you can talk us through how we go about simplifying this?
Yes, ma'am. So firstly, what we do, ma'am, we divide all of these numbers by 2.
Okay.
So 10x cubed will be divided by 2x, and then minus 4x squared divided by 2x,
Mhm.
and then 8x divided by 2x.
Okay, perfect. So we're, oh gosh, that's a terrible sound to hear my own voice. So we are dividing everything by that same denominator. Excellent, keep going.
And then after that, once we have divided all of these numbers, we'll from 10x divided by 2 we'll get 5x, and then 2, and then 4x divided by 2 will be 2, minus 2x, minus 2, just minus 2, and then
Oh gosh, sorry, hang
2
on, I forgot
divided
this.
by, okay, and then 2 divided by 8 will be 4.
Excellent, thank you.
Javiso just noticed something. Oh,
Thank you,
yeah.
Kabiso. Okay, so Kabiso, thank you. Clearly my brain is now tired. Do you want to add? Oh no, okay. So as Naledi told us, what we essentially want to do here is we want to take each of the terms in my numerator and divide it by the denominator. Now, one way to do this is to write out all your fractions separately. You don't have to do this. If you're comfortable with this and you can just do it quickly in your head, go for it. The one way to make it a bit easier and to make sure that you remember each one step by step is to write out your fractions. Right, I do apologize. Forget that it was x cubed, not x squared, and that it was x squared, not x, but we've got our exponents correct now. When we go and divide, again, you can use SNV. This works with both multiplication and division. And so, for example, if we look at our very first term or the very first fraction, S, it's a positive divided by a, well, English, I'm going to try that sentence again. It's a positive divided by a positive. So we know we've still got a positive. We don't have to write the positive there, but we know it's positive. Numbers, 10 divided by 2 is 5. And just quickly, so that we're all on the same page again with this exponent thing, if we think about x cubed divided by x, this goes back to our exponent laws. When we divide with exponents, the law tells us that we can subtract the exponents. Now, we've got an exponent of 3 and an exponent of 1. When we subtract that, we get a squared, so an x squared. Another way you can look at it is, and this is how I do exponents, is you can say, okay, cool, well, I've got 1x in my denominator, 3 x's in my numerator. I can cancel 1 at the bottom, cancel 1 at the top, and I'm left with 2. It really doesn't matter. I prefer this method, but however you choose to do it, it's up to you, as long as you apply the exponent law. The same thing then happens with the next two fractions. Now, in the second fraction, and this is just what I want to point out, there is a minus here. So when you deal with your signs, essentially you're dealing with a minus divided by a positive. And a negative divided by a positive is a negative. So we need to just be careful of our signs there. The exponents, same law applies. For the last fraction, what I want to point out is that we don't have any variable in this last term. Now, the reason for that is whenever you divide something by itself, so x divided by x or 5 divided by 5, whenever you divide something by itself, it gives you 1. And because we then know that anything multiplied by 1 is still that value, so 4 times the 1 that we get when we divide x by x is still 4. We don't have to write anything there. And so essentially, those x's cancel or they divide to give us 1. And that has no effect on our term. So we don't have to put anything down there. But just bear in mind those x's are gone. We don't write an x there. All right, guys, have I simplified fully? Is this my final answer? Can I do more? Can I simplify further? Do I have any like terms here? Good. No, I'm done. There are no like terms here. I can't do anything with the situation. It's done. This is my final answer. Excellent, guys. Okay, I'm going to leave it up here for a second in case anyone wants to take a screenshot. Tassel, do you have a question for us?
Yes, ma'am. The question of 2.2, ma'am, I wasn't able to take a screenshot fast enough, so can you please go back to it?
Let's do that. There we go.
Thank you.
Sure. Okay, guys, if you didn't get a screenshot of 2.2, there it is with 2.3, so you can get both at the same time.